Hey, what's up everyone? I am back with another repair video, and this board may look similar because I just did a video on this board. Well, not this exact board, but an XTR, a ThermoFisher Sorval Legend XTR benchtop centrifuge main board. Um, so this board actually came out of a centrifuge that the end user was complaining about a weird smell emitting from the centrifuge. Definitely like a, like a biological, yeasty, something like some sort of contamination type smell. Um, and so I did take a look at it. It turned out to be the rubber boot that seals the bottom of the chamber. It had nothing to do with the main board, but I took the board out to kind of clean the area around underneath the underneath the chamber, inside the chamber, and this board was working completely fine. And then I popped it back into the unit, and it started throwing an E25 error. Very odd because I didn't do anything to the board. So yeah, E25 is a latch timeout error. Um, so timeout latch opened. Okay, now that was actually my first thought. Um, there are micro switches on the latches for these units. There's 4 per latch, and one in particular likes to go bad. Not even the latch, the micro switch itself, but the leads to the switch. I'm going to show you guys that in a second, and that's initially what I thought it was, but it turned out not to be the case. It had nothing to do with the latches. It's definitely something going on the board. But yeah, so what we're gonna do is, so I've already verified a couple things that I did in the last video, so I'm not going to do those again. Basically, I've confirmed that all of the signals from the micro switch are making it to the to the um, to the microcontroller when the latch is in the open state. Neither latch is responding to pressing the open button to get, because you can press that button just to get the latches um, to the motors to rotate. So neither of them is working. At one point one was, but now neither of them are. Another thing, and I can show you this in a second, is the voltages measured on these pins here look a little bit different than what I've seen in working boards, and I can show you guys that as well. But what I think we're gonna have to we're gonna move on to figuring out, are these H-bridge motor controllers, are they getting the correct input signal from the microcontroller when the open button is pressed, and a few other things as well. But anyway, let's get started and see where this takes us. Alright, so before we get out and power up the board, I did want to just kind of go over a few things in the schematic, just to kind of clarify what I was referring to earlier. Okay, so our area of interest, or at least what I am interested in at this point, is the latch circuitry, and this guy right here. This is the TL-5206. There's one for each latch. It is a motor controller IC, and I'm curious to see, when pressing the open button, are we getting any signal? See this in 1, in 2, that's going to the microcontroller, okay? And that is a output from the micro going to the input of this TLE-5206. I want to see if when I press the open button, are we getting any signal there? So that I want to verify for each latch. Another thing that I'm interested in is this signal here, this OC_lid. I think that stands for open close lid. I want to check that as well. But mainly this in 1, in 2 to see what's going on there. Also, this lid lock motor error flag pin 8 check that as well. Is this thing throwing any error codes? But that's going to be my main area of focus, I think. Alright, this thing's going to start beeping in a sec, so I apologize for the beeping. It's annoying, I know. But I did want to just show you guys real quick the voltages at the two latch connectors, X16 and X15. Okay, so just starting with latch pin, the pin number 1 on X16. So we have 5 volts, which is right. It's a little bit above 5. Pin 2 is 0. That's normal. Pin 3, now this is what I'm talking about. So this is roughly 2.7 volts. It should be around like 2.5, right on the dot almost. And then if you look at pin 4, now we're at like 2.4. And that should also be closer to 2.5. I know it doesn't seem like much, but I used this board as a reference for checking the other board I just worked on, and really just I only made these 2 measurements on it, and that's it. You know, I wasn't using it for anything else, which is why it's perplexing that it just stopped working. But anyway, I know these voltages were different before this happened. They were definitely closer to just 2.5 for both of them. I think at this point now, let's take this board, let's bring it out to the centrifuge, and check the inputs to these motor controller ICs to see what's going on there. Alright y'all, so we've got the main board hooked up to the centrifuge, and we're gonna test for a couple, we're gonna make a few measurements. So first, we're gonna just make sure that the voltages are making it, the signals from the latches are getting to the microcontroller. Alright, now again, I've done this before in the last video, but we'll just do it here again real quick. But before we do that, I just want to show you, I don't think I've actually showed these latches in detail before, and it'd be easier if I took one out of the centrifuge, but I'm a bit lazy, so I'm going to do my best to show you guys the switches. And so yeah, let's see if we can get in here and see these. So you can just about see this guy here. You can see the latch actuator. So this is the lid hook down latch. So when that lid hook comes down, it's that latch that is switch that's activated. Whoa, there was just a really nice lightning strike out front. But anyway, so that's one switch, and actually it's this switch that has the most problems in my experience, because you can see those leads that are coming out of it there. Well, this is on a moving part, and when this thing keeps constantly moving, it actually ends up breaking these leads right at the switch, and you have no other choice but to replace that microswitch. The hilarious part of all this is if you tell this to ThermoFisher, they will say these latches are not repairable. If you try to take it apart, the act of taking it apart will break it. Okay, I can actually embed a photo from that email exchange where one of them said that, if I can find it. But so that's one latch, and that's the one you have to replace very often, and it'll throw errors like this if those leads break. The next switch is one of these down here. These other switches I haven't had to ever replace, but I imagine they could also go bad eventually. So it's either this switch, and then there's another one. Let's see if I can angle this properly. Yeah, because you can see these two switches here. One of these is the snap position switch, and then another is the lid close switch. I'm not sure which is which, but those are both of these two. Oh man, there's another lightning strike. And then all the way in the back, you have the emergency release switch that will be activated when you pull that cord back there to manually open the the lid in the event of a power outage or whatever. So yes, there's 4 of these micro switches on there, and we're interested in measuring the signals coming from those first three that I mentioned. But anyway, let's power this guy on, and we're going to check these for each latch. That's the first thing we're going to do. Alright, so you can see here the lid is opened. It says lid open, so far so good, right? But yeah, let's just check 96 for X16 and 94 for X15. This is the lid lock closed. So the latch is open. We should be getting 0 volts for both of these. Alright. So you guys just watch the meter. Alright, so we've got roughly 0 volts there for 96. 0 volts there for 94. Okay, so that's good. Alright, and then we'll check lid lock closed, which is, oh, I'm sorry, that was lid lock closed. So now we're going to do the snap position. So that's 95 and 93. 95 for X16, so we got 5 volts, and then 93 for X15. 5 volts as well, and then lid hook down. So 7 for X16. So that's 5 volts roughly, and then 6 for X15, and also we're at 5 volts, all right? So the signals, that is normal. That is what you should be getting with the lid open. Those signals are making it to the microcontroller. There's no interruption there, and that is confirmed by the lid open on the display. Okay, next thing I want to do is try to press the lid open switch. So just pressing the lid open switch right here, we should be seeing these motors rotate, okay? And while I do that, I would like to see if there's any input signal to one of the motor controller ICs. So actually, you know what? In order for me to do this, gonna have to get my camera mount so that I can measure and press the button. So give me 1 second. Ooh, check this out, guys. We got quite a storm coming through Philly right now, and that's why I kept seeing those lightning strikes in the corner of my eye, getting distracted. But I don't know if I ever mentioned this, but I'm also a big weather nerd, especially severe weather. I love watching storms. But anyway. Alright, y'all, so I know this isn't the best angle, but just you guys can see the meter. And so again, there is a storm going through, so you're gonna be hearing some thunder, so I apologize for that. I love that kind of stuff. Oh, there's another strike. Wow. But hopefully it's not too annoying. If not, I'll stop. But yeah, so what we're gonna do is we are going to I'm going to be monitoring the input to one of these motor controller ICs. You can just about see one in the corner right there. Alright, and so I just want to see if by pressing the open button we get any signal whatsoever going to that motor controller IC. And I might have to repeat this a couple times to just check each one to see if we're getting anything from any of them. Alright, so let's do that. I'm going to put my test lead on pin. Wow, yeah, that's quite a storm coming through. Alright, so I got my test lead on pin 12. So that's input number 2 to this, what I believe is the X16 motor controller IC. And then I'm going to press the open button. Watch the meter if anything happens. Yeah, so nothing. We got nothing. Alright. And that beeping is the display reading E25. Alright. Now I'm going to repeat this again. I'm going to check input number 1 on this, just to see if we're getting anything at all. Alright, so again, I'm going to be putting this on pin number 9, which is input number 1 of this motor controller IC. And I'm going to press the open button to see if we get any input coming to this IC. Oh. Okay. Alright, so you did see that there. We did get 5 volts. But that was it. And then nothing. Very interesting. Microcontroller is sending a signal to the motor controller IC. Now, what we're going to do is look up what that means real quick. Let's look at the datasheet and see. So we had 5 volts at pin input 1 and 0 volts at input 2. So let's look at the datasheet and see what that is, what that means. Alright, so this is the datasheet for the 5206-2. So we had low on, high on input 1, low on input 2. It means it's trying to turn that motor clockwise, which makes sense. Let's look at the other one and see what we get as well. Alright, Chelsea, we're going to check the next motor controller IC and see if we get anything similar to what we got with the first one, which I believe is for X16. So I guess this is X15 just based on its proximity on being on the right side. So let's just check pin 12, which is INT 2, input 2, and we're going to press the open button to see what happens. Oh, okay. So that one did go up to 5 volts. Interesting. Alright, so now we're going to check input number 1, pressing the open button. And we got nothing. That's interesting. Let's check that one more time, because that would mean you'd have 2 motors turning in the opposite direction, which just doesn't make sense. They both need to be turning in the same direction every time. Whether they're opening, let's say for example, they need to open, they're going to turn clockwise. If they're going to close, they're going to both turn counterclockwise. So that is concerning, because we got the opposite for both of them. So let's just verify that real quick. So I'm going to shut it down again. Okay, and I am on pin 12, input number 2, on the X15 motor controller, and I'm pressing the open button. Yeah. Yep. Unless I'm remembering incorrectly what the first one was. Let me just double check that. Yeah, see? It is the opposite. That is so odd. That just doesn't make sense. I would assume they would both be turning in the same direction. And we know that the microcontroller thinks they're both in the same state. So I don't know why it would be doing that. Okay, so this is interesting, guys. I don't know why I didn't check this earlier, but the output is also being there's output voltage. There's signal coming from the output of these motor controller ICs. Watch this. So let's restart this. Well, first thing I want to do is we'll start with the right one and repeat, just so you guys can see on input number 2 the 5 volts as during the startup. It's that 5 volts. Okay. And then of course it goes into E25. I'm going to shut this down again. And then we're going to check. So this is input number 2. We're going to check output number 2, which is pin 14. But watch this again. Look. Now we're getting 25 volts. It's following the input. So with that in mind, I think I'd like to just replace these shunts. These are the same shunts that can cause latch issues. Replace those. I don't know if that'll be the problem, but I don't know if that's what's causing this, but you know, I think I was going to do it anyway, but what is, yeah, let's do that. Someone's been here before. I can definitely tell you that was not me. But let's replace these shunts. Alright, so I replaced the shunts. Let's just pop it in, see if it makes a difference. Alright, let's just see. I don't have high hopes for this, but one thing I will say is, I don't know if I caught this on video, but what you guys did see is that the output is changing with the input. So for example, 5 volts on the input 1, you get 24 volts on output 1. I think this is what I checked off camera. That 24 volts is making it to, was making it to the original shunt. So why the motor wasn't spinning, I'm not quite sure. But, so let's give this a try and see what happens. Alright. Try opening it. Are you kidding me? Wow. They're both working now. Are you serious? Are you serious? Hold on. You just set the temperature to 20 so we don't get any errors. Let's try and close it. Oh my god. It was the shunts. Unbelievable. That is amazing. I can't believe that the shunts were the problem. So this proves that technical note that was released for these shunts. I mean, because guys, I literally just popped this board out because that boot smells like crap. And then I figured I have the board out. Why not use it to troubleshoot as, you know, as a reference for this other board I was working on. I literally took a couple measurements from the connectors. That's it. And then it sat for a while. And then I went to start putting this thing back together, and it started throwing that error. That is incredible. And it was the friggin' shunts, it looks like. Unbelievable. Wow. Wow. I can't believe that. Well, I'm glad, you know, this board I just did actually, I replaced those because of that technical note. I'm glad I did, because it seems like it could happen literally overnight without even, wow, I just can't believe that. I mean, I'm glad that's it, but that really, I just didn't think that was I just didn't think that was going to be it. But okay. It makes sense as I was getting closer to it, though, because again, the 24 volts was making it to those the shunts, which, you know, yeah. So that's interesting. All right, I think I'll put this guy through some of the similar testing that I did on the last one. Just do a quick cycle. But other than that, I think, then I'll wrap it up. So we'll do that real quick. Yeah, so this is actually what I was referring to. It's not an official technical note. I'm sure there might be one that exists out there, but this is where I found it. I found it on this website. It's called Ozark Biomedical. They are a centrifuge parts supplier, and they also repair them. And you can see here, if they it says it'll intermittent issues that mimic a defective latch assembly. That's exactly what was going on. And they point out these old style shunts, and then this is the new style, which is basically the same thing that we put in just now. I have noticed this newer style in some of the other XTRs that we have in service. If I come across any other ones that have these, I'm definitely going to replace them. And that's actually this document is actually what prompted me to keep these new style chokes in stock. That's why I had them in the first place. Yeah, this is a helpful website. They offer parts, and they do have, so here for example is so they do have this exchange for motors and PCBs. That's a bit pricey. I don't understand why they just can't repair yours for you, but it's still a service that they offer, better than just I do respect that somewhat. And the latch exchange as well. I mean, this is how expensive these latches are. Over $1,000, and then they're charging $800 for you to exchange one, and that's kind of ridiculous. But look, it's better than some services out there. I'll give them that. But anyway, that's a wrap on this guy. I still need the rubber boot to come in before I can pop this guy back in. It will stay in my shop until that part is delivered. Hopefully nothing else mysterious happens while it's in my hands. Because I gotta say, when this happened, I was a bit embarrassed, bummed. When you are an engineer or technician, whatever you want to call us, you're the guy who's supposed to be repairing these things, not breaking them. All right, so I really was scratching my head as to what I did to cause this in the first place, because I barely touched it. And it does make sense at the conclusion here. In some ways, it's a blessing in disguise that this happened now while the instrument is down. So that way, I put the boot in, pop this board in, and then who knows, days later it starts doing this again. So then it got to take the thing back out of service. So in the end, it kind of worked out nicely. All right, so just again, these shunts, check them. If you have them in your XTR, replace them. It's an easy repair to do. If you're good with a soldering iron, you're seeing an E25 error like this, or some of these other E24, E25, obviously check the latch first, but if it's not the latch, could be these shunts. Hopefully this is the last, maybe for you guys, it's the last XTR mainboard repair that I have for a while. You guys might be getting tired of them, but they are a fun board to work on. I mean, there's so much going on here, especially for someone like me who learns by repair. A lot of different concepts are on this board that you can learn about and teach yourself. So it's pretty neat in that regard. But that's a wrap. I hope you guys found this interesting. As always, if you got any feedback, please leave it in the comments. If you like what you're seeing, please subscribe, and I'll catch you guys at the next repair. All right.